Okay, it looks like people hear me, so let's go ahead and get started here. We're going to be talking this evening about putting regular expressions to work. Some of the things we're going to focus on during this session is talking about how to use regex from the command line editors, Ruby, JavaScript, but we're not going to actually be talking about how to construct regular expressions. I'm assuming that you're already familiar with them and that you're also familiar with the command line in general. If necessary, you can go back a little later and read our two books, Introduction to the Command Line and Introduction to Regular Expressions. And the last part of the session, we'll talk about how regex isn't really a hammer. Not everything is a nail. So let's go ahead and get started. We're going to start with the regex at the command line. So that's usually one of the easiest places to use them. For starters, let's take a look at wildcards. They're not technically regex, but they're very similar. You may know the ls command will show you a list of the files in the current directory. And you can use a wildcard like star to match anything from between 0 and however many characters you want to talk about. Actually, I think it's one to any number of characters. So if I look for star.txt, we end up with the 3 txt files, ABC, ABCD, and X from the original list. There's also a question mark wildcard, which matches exactly one character. In this case, we only get the x.txt file. From there, we can start looking at grep, which is where we actually start getting into regular expressions. Grep is a program that has been around for many, many years. It stands for Global Regular Expression and Print, which basically means that it searches and prints stuff using regular expressions. It's like I mentioned earlier, it's the easiest way to learn regex, and it's got a lot of different variants. There's egrep, fgrep, agrep, pcre grep, and a whole bunch of different ones. Every one of these greps has a different type of, it has different regular expressions it uses. It has different purposes. For instance, agrep does fuzzy matches. It looks for things that's almost the same. Whereas pcre grep uses Perl-based regular expressions instead of the type of expressions that most greps use. And I'm going to be using the GNU version of grep, which is what most of you will have on your computers at some point, at least if you're using a Mac or Linux. So let's take a look at some of these. For starters, we're going to look again at the total list of files that are in this directory. Notice that this time we have a txt file with an uppercase txt. That's going to make a difference when we're using the regular expressions. And let's take a look at a few of them. You can see they're fairly simple files. They're just simple list of names. Some of them are capitalized, some of them are not. Let's find the names that begin with a lowercase j. For that, we can use the grep command with a regular expression that looks for an anchor and then the letter J. And then we're looking at the txt files. And you can see we found John, Jane, and John The first two came from the first file. The second one came from the second file, and the uppercase versions in the final file did not get found this time because we're only looking for the lowercase j. Excuse me, my voice is getting a little hoarse already. To include those lower uppercase versions, we can add the -I option, which means case insensitive. And there you can see we added the James and Jane from the third file. We can also find files where names that end with an E using the dollar anchor. And we found those 4. And you can, of course, even find just a plain old letter if you want. It's the same way, works the same way. And one other variation you can do is you can use what's called a pipe. In this case, we're going to take the ls command and we're going to send it through a pipe. And this time I'm finding the case-insensitive version of txt, which finds our uppercase version also. It also found the txt.doc file rather than the ones that ended in txt. Any questions so far? Okay, let's move on then. And we're going to talk about now move on to regex in the editor. This is one of the places where you can really get into some of the advanced regex techniques, as you'll see in at least one of the exercises, or at least one of the examples I'm going to show. Most editors support regex of some sort. We're going to talk specifically about Atom and VIM. Atoms is very similar to the version of Java both of them have versions that are very similar, or I should say, Atom is very similar to the versions of regex that you find in Ruby and JavaScript. VIM is quite a bit different, as you'll see. Let's take a look at this example 3 here. Oops. Okay, we're going to search here for words that are 7 characters long or longer. As you can see, if I enter a regular expression in the find box right now, nothing happens. That's because we're not searching for regular expressions. But if you look at this button here, it says use regex. If you click that, it's now identified all the words that are 7 characters long or longer. You can also do search and replace using these. Let me make sure I get this right. Come on. If you notice this time I'm using a $1. That's a refer back to the item in parentheses. This is going to replace all the lines that end with a new line, and it's going to join them all together by replacing the the dot asterisk part, and then adding a space. We can do first find all, and then replace all, and everything goes into a single long line like that. And I should have done a better job of putting this stuff on a separate place here. Now let's take a look at this in Vim. In this case, we're going to start with the one single long line that's not been wrapped, and we're going to unwrap it. For that, we are going to use, we'll start by searching for those 7-letter words first. For that, we use slash. Oops. Sorry. We need /W for looking for the word characters. In this case, I'm being a little bit flexible in saying a word character is anything other than a word character is any letter, number, or underscore, which doesn't really matter in this example. And then, because this is VI, I have a slightly different regular expression I have to use. I have to prefix the brace with an escape character because that's what this version of regex expects. And I also need to do that with the closing brace. And unfortunately, I managed to turn off the highlight. But you can see that the cursor is jumping to the longer words. We can also find the lowercase words. In this case, in Ruby and JavaScript, you would use /B. Here, you have to use /<, another slash for the plus, and then >greater for the closing /B. And this finds all the lowercase words. If you want to, if you want to make something case insensitive, you have to use this :set IC command, and then you can just repeat the regular expression using slash, and this time it'll find all the words regardless of the case. And now let's go ahead and wrap that up. And this one is somewhat complicated. This is the one I warned you about. For unwrapping, we're going to use :S, which is a substitute command. And it starts with a regular expression. Let me make sure I get this right. Unlike Adam, this one uses /1 for the refer back. And then to enter a new line, I need to enter a Control-M, which I do by Control-V, Control-M. And then I'm going to do it globally. And it did not work, unmatched. Missed that. And it's not working. I'm not quite sure what I'm doing wrong at the moment, but the basic idea there is that you can use the appearance of the regular expression in VM is quite a bit different than it is in Atom, with all those backslashes. And if you want, you can always use a different character for the to separate the first part from the second part. In this case, I'm using a comma instead of a slash. Any questions here? All right, let's go back. And now let's look at Ruby. And we're going to talk here about basically three main function method categories: matching, splitting, and then substitution. In Ruby, you can match match a regular expression using the string match method. You can also use equal, tilde, and then if you're working with strings, you can use the equal operator, which is what you get when you're running a case statement. We'll see all three of those. Okay, let's take a look here at our first Ruby example. We've got, in this case, we've got an array of several different objects, and we're going to try to print all of the animals where there's a particular type of cat. We want just the second item here, and then the last item. We're not interested in caterpillars. So I have to search for a cat which is a word all by itself, and I need the /i to indicate that's case sensitive. And I'm just going to apply that against the animal type with the match operator. And as you can see, we got the two items that we're most interested in seeing: the cat and the jungle cat. In this slight, very small variation, we're going to use equal tilde instead of match. And as you can see, the results are again the same. The main difference between match and equal tilde is in terms of what it returns. Equal tilde returns basically a copy of the match. I believe it's a copy of the matching string, whereas the match returns an array of strings, which can include a lot of different subgroups inside this regular expression. For the most part, you can use whichever one you prefer. Stylistically, I like equal tilde when I don't need all the details. I just need to do a test. But that's up to you. A somewhat different method here is a split method. Split takes a string and converts it to an array by doing a split on either a string of characters or a regular expression. In this case, I'm going to do a split on a regular expression consisting of a comma and a colon. So it's going to split each of these items up in this string into little arrays: type, name, and age. And then I'm going to do the same type of operation on what remains. As again, you can see we've got the same results. The main thing I did wrong here is I forgot to convert the age to a number, but that's not significant in this particular problem. The equal operator comes into play when you're using the case statement. If you're matching against a word, if you're matching against a string, you can use regular expressions on each when clause. In this case, we're going to match for words that are 6 characters long or longer, words that are 4 or 5 characters long, and words that are 1 to 3 characters long. And we'll proceed with a long, short, or nothing at all. And you can see again, we got what we expected to see. Oh, by the way, this is actually an array here, so we were matching one word at a time. And that brings us down to sub, which is a function that substitutes a value. In this case, we're going to be substituting a regular expression, and then the block here takes that provides the replacement value for the matched expression. In this case, we're only matching for one occurrence, so this is going to match the first word that begins with a vowel on each line. So that should get all right. Okay, yeah, so that'll get us the first word here, the first word there, and the second word here. And you can see it capitalized the first word, and second word, while leaving everything else alone. And with the site variation, we can change that to capitalize everything that begins with a vowel, all of the words that begin with a vowel, by changing sub to a G sub. And again, you can see everything is uppercase except for the consonants. Any questions so far? Okay, let's kind of on over to JavaScript. And in JavaScript, we have 3 very similar functions to what we just saw in Ruby. There's match, split, and replace. Match and split do basically the exact same thing as the Ruby counterparts do, and replace does the same thing as G sub, basically, or sub and G sub simultaneously, actually. So let's take a look at them. All right, this is a lot like our first example. We're starting with an array of objects. And again, we want the cat or the jungle cat. So we're going to loop through that array. We're going to use the match method, and we're going to use /b cat/b with the I operator. This is just like the Ruby equivalent. Oops. And you can see we got the same results as we did in Ruby. This is our example using split. Again, it's the same exact thing we did in the Ruby variation, except now we're using JavaScript to do it. And again, we get the same results. This one is a lot like our sub example. We're going to replace just the first occurrence of a word that begins with A-E-I-O-U with the first character replaced by an uppercase letter. And in this case, we use the replace method with a regular expression and then a function that returns the desired value. And as you see, first one, and second one are all capitalized. To change this to produce, to get all the all the vowel words capitalized, we just replace that. We just add a /g to the end of the regular expression. And you see the difference there. Any questions? Everybody's being silent. I hope I'm not boring you to death. Okay, and that's a very quick tour of what you can, how you use regular expressions in a variety of different situations. One of the things you want to know about, well, one of the things you need to deal with regular expressions is to not get too, don't fall in love with them. They aren't a hammer. Not every problem is a nail looking for a regular expression. You can do an awful lot with regular expressions, but that doesn't mean you should always use them. They can be hard to read, so use them sparingly. Use them when they make sense, when it's easy to understand. Avoid complex regex like that one I failed on earlier in the program, earlier, because that will get you in trouble, and avoid the advanced features like back references and forward references and so on. Keep them simple. Whenever possible, try to refactor things. I like to use this example where we're trying to match strings that either have quotes, double quotes or single quotes, and you need this back reference here, and so it's a fairly complicated regular expression, and you can simplify that quite a bit by just splitting it into two separate regular expressions joined by an or. It's easier to read, it's easier to understand, and it's easier to maintain. And one thing I want to definitely point out is when you use it in your editor, be careful, especially if you're trying to do a global search and replace. It will bite you if you're not careful. Don't save your work until you're absolutely sure that everything worked the way you expected. And that pretty much covers everything that I was going to talk about. Does anybody have any questions at this point? Wendy asked if she could have some of these examples. I think I could post some of the examples somewhere where you can take your time to go back over and look at them. Kurth asked if it's okay to use the backslash on every meta character in VIM. And I think generally speaking, yes, it is safe to do that. You have to use them on asterisks, on plus, on parentheses, on braces. It's real. VIM does not really work. Well, I won't say it doesn't work, but it makes it tough to use the regular expressions. Anybody else? Okay, I'll try to get those examples up sometime, probably tomorrow. Thanks everybody for attending. I hope you found this worthwhile, and we'll talk to you later.